Now in the previous few videos we looked at simple exponential smoothing. Now one of the reasons why simple exponential smoothing may not perform well is if the original data shows a trend, the simple exponential smoothing is unable to handle that trend part. So the linear exponential smoothing takes the trend into account during the smoothing process. And so this model would compute better, more accurate forecast than SES. So it's called LES, linear exponential smoothing, where we have the base part like the exponential smoothing, but in addition to that, we also take the trend from going from one period to the next, and smooth that as well. And then we add the smooth trend to the base to come up with the forecast into the future. So forecast one period looking ahead will be the base that we smooth, called L sub t, or the level of the series, plus the trend part, T sub t, and the formula is this. So the formula for smoothing L sub t is L sub t minus 1 plus T sub t minus 1. So that's the forecast for period t. So that part is F sub t. So F sub t plus alpha times part of the error. So this is the same formula as the simple exponential smoothing. So the L part is same as before, but in addition we have the trend part. T sub t is the previous trend plus now we are introducing a second smoothing coefficient. Instead of alpha we use beta, and the difference between the L and the F. So what is that difference? So that would be the trend smoothing. So we use once again alpha and beta must be less than or equal to 1. Now we have to come up with three initial values, well four, one for alpha and one for beta, and we use this thumb rule. So any value in this range can be used as the initial trial value. Of course we will use solver to find the best alpha beta combination for minimizing MSE or minimizing MAE. And the L and T values, the initial values can be, you take the difference between Y sub 3 and Y sub 1 and divide by 2. So that is going from Y1 to Y2 and Y2 to Y3. So the two periods. Yeah. And what has been the increase, and that would be our initial trend value for time period 3. And so L sub 3 will be the average of the first three Y values plus our initial estimate of T. So that will give us L sub 3. So L sub 3 plus T sub 3 will then become the forecast for F sub 4. And that's how our forecasting model can begin, and we can set the rest of them up. So let's now go to Excel file and set this model up. Okay, so here is the data. So let's first plot the data, see what it looks like. So we can use scatter plot, connecting the points. Okay, axis titles. So this will be period, and that is sales, and you can see there is a clear trend in the data. So let's use it for initial value 0.3 and 0.1. Okay. Then so we have to set up our initial values. We first set up the initial value for trend, which is Y sub 3 minus Y sub 1 over 2. So that will give us the trend, initial value for trend, and then we do average of the first three values plus the trend, the initial trend that we have computed. Okay, now we add that initial value of L and the initial value of trend, and that will be the forecast. So error would be the actual value minus the forecast will be our error. Now we can set up the formulas for level and trend. For level, okay, it is the forecast plus alpha times alpha should be absolute referenced times the error. So that gives us the smoothed level value. Okay. Now the trend is previous trend plus beta time plus beta should be absolute referenced times L minus F. So L is right there minus F. So that will give us the smooth trend. So now we can copy these four the rest of the way and put the border back. Now we copy the forecast one step forward, and that gives us the forecast for time period 13. Now we can add the forecasts into the graph and see how that will look like. So select the graph, go to design, select data, and you add, okay, it's called the series name forecast. Y values are the forecasts and the corresponding X values are 4 through 12. Okay, so now we can add legend, and let's put the legend at the bottom. Okay, so there you go. And now we can set up our error measures using 5 through 12. So we want to use forecast 5 through 12 in setting up these error measures. So ME is simply sum of the error measures. Okay, MSE is the forecasts are here in column E. And then RMSC, MAE, MAP you set up in the same fashion. Okay. So now you have set these three things up, and MAPE is a percentage. Now MASE is the same two ranges like before. Then we want to compare that with random walk. So random walk forecasts now are for weeks 5 through 12. The forecast will be the actual values from weeks 4 through 11. So those are the three. Okay. Now I said tells you the same way, and here it is. And we can see that the LES model is definitely better than random walk, except we have to be cautious here since we had only 12 periods worth of data. We are not able to split the data up into the modeling data and the holdout data. Okay. And for that to happen, we need to have a large enough data set. Then we can be more confident about how good the model is. So right now, it looks like this is a better model than random walk. There is good evidence for that. But still, if we are able to check it out with actual future data, we can be much more confident.